Hey, chemistry people. Let's get started by logging into Clever. All right, so I hope that you have completed assignment number 62 at this point. So if you have, I'd like to know something that you learned while completing the periodic table scavenger hunt. If you haven't done it yet, can you just maybe tell me why you haven't? All right, so we are on week 14, lesson 27. We are diving into some other patterns of the periodic table besides just thinking about our valence electrons and our electron shells or the mass. We're going into some other patterns and trends. So, some reminders. Grades were posted last Monday, but that does not mean that your grade is final. You still have several weeks ahead of you to bring your grade up or drop it down if we're not doing what we need to. So, my recommendation is to keep working. If you're trying to get caught up, keep taking a chunk at a time to get caught up, a week at a time even. Don't forget to do those ed puzzles, anything that has a number sign. So has like a hashtag or a pound sign and a number. Those are required of you. And so every week you at least have one. And those week previews, that's what I'm talking about. They have the same weight as any other assignment. So make sure you're doing those because they are like pretty much freebie cushion points for your grade. Make sure that we're remembering our expectations. And thank you guys for being here. Let's dive into it. So like I said, this week we are talking about more patterns. There are two assignments that I'm going to discuss at the end of the period. And all of this is in preparation for a big assignment that we're doing next week. You're here in this lesson 27. After this lesson, then you should give assignment 63 and 64 a shot. If you have no idea what you need to be doing on 63 and 64, make sure that you're watching this lesson first. Opening up your periodic table is probably a good idea. So links there now. Great. So this first question is another one for us to practice being able to figure out where on the periodic table an element is based on its valence electrons and its shells. So remember the valence electrons, those are the electrons in the outside shell of an atom. Every element in a column has the same number. And so these numbers on top here represent how many valence electrons every element in that column will have. The electron shells are then represented by the rows. As you go down the rows, you add another shell. So what atom or what element has two valence electrons and two electron shells? All right, so our correct answer is beryllium. So it has two valence electrons, so in the 1, 2, second column, and then the second row. So that puts us at 4, beryllium. All right, what about this one? A little bit more challenging. 6 valence electrons and 4 electron shells. So let's walk this one out. 1, 2, 3, 4, 5, 6. And we need to go down to the 4th row. So that's 1, 2, 3, 4. All right, and then we're over to 6. The correct answer is 34, selenium. Good stuff. All right, so we are diving back into thinking about patterns and trends. So let's start with this. What is the pattern in these numbers? So you might have noticed that between the 7 and 8, there is a difference of 1. Between the 8 and 10, there's 2, 3, 4, 5. All right, so the pattern is you're adding by 1 more between each number. So using that pattern, what is the number that would come after 22? So if we have plus 1, plus 2, plus 3, plus 4, plus 5, plus 6 would give us this number. 22 plus 6 is 28. All right, so this is another way to look at a pattern or make a prediction. So number of rainy days, that's what's behind here. Sorry, my face is in the way. And number of umbrellas. So what is the general relationship between rainy days and umbrellas? So you might say that the more rainy days there are, the more umbrellas there are. So you notice that although it's not a perfect line, the general trend shows that as the rainy days increase, so do the number of umbrellas. Makes sense. Now, there's a part of this graph that you can't see. But you can predict what that number might be based on this trend right here. So based on the graph, and the word is to extrapolate this graph out further to 20 rainy days. So all the way out to the right. How many umbrellas do you think there might be? So a lot of you guys said 20. Yep, because at 10 and 10, it also would totally be appropriate to say like 18, because this trend line here, if that were to keep going straight out until 20, if it's at 9 at 10 days of rain, that means it'd be 18 umbrellas at 20 days. All right, so this idea is important because we're going to be looking at and making some predictions based on very, very basic trends. So this is, again, in preparation of an assignment that you're going to have next week. Don't worry, we'll spend a lot of time getting ready for it, but where you're going to be predicting the placement of a brand new element based on a set of properties, okay? So we're going to be looking at, I think it's 5 different patterns. These first 2 we're just reviewing because this is what we focused purely on in our last lesson. And then we're going to dive into some other patterns and trends that you might find on the periodic table. So the first pattern to think about is our valence electrons and our electron shells. We now are very confident in the fact that every element in a column will have the exact same amount of what are called valence electrons, or electrons in the outside shell. As you go across the periodic table from left to right, or I guess with my mirroring here from left to right, you are going to see that the number of valence electrons increases by 1. So in this first column, they all have 1. In the second column, they have 2, 3, 4, 5, 6, 7, 8. So as you're going from left to right, the number of valence electrons increases. For thinking about our shells, remember the row tells us the number of electron shells that an atom has. And what you see there is that as you go down, another shell is added. So the first row, they have 1 valence electron. The second row, as you go down, they have 2. The third, 3, and so on and so forth. So some of these patterns or some of these character traits that we're going to talk about, it's not super important that you know exactly what it means. So this first one that we're thinking about is ionization energy. So even though I just told you don't have to know what it means, essentially what it is it's talking about the amount of energy that it takes to make an atom an ion. So some of these atoms really, really want to gain electrons to become an ion, and some of them don't. So the higher energy ones, that means that it's going to take a lot of energy to turn them into that. So if we look at this general chart, we can look at the numbers. We would notice that as you go pick a column, as you go up the column, there are a couple of don't follow the rule exactly, but in general, you'll notice that as you go up the periodic table, the ionization energy increases. Okay. Now you also then can notice as you go across the periodic table is that, again, there's a couple of imperfections, but you'll notice that the ionization energy, those numbers are also increasing. So the general trend shows that as you go up the periodic table and then as you go to the right, the ionization energy increases, with the largest ionization energies falling over here in this top right corner and the smallest ones in the bottom corner. So let's check that we fully understand that. Ionization energy blanks as you go up the periodic table. So as you go from the bottom to the top. And this is a trends chart that you're going to see a lot of. It kind of combines all of the trends that we're looking at. So I want you to be comfortable with it. So the ionization energy, the arrows always point in the direction that they are increasing. So as we're going from the bottom to the top, what would we say about the ionization energy? Fill in this blank. So the ionization energy increases or gets bigger as you go up the periodic table. What about as you go from left to right? It also increases or gets bigger. All right, so based off of that, following this trend, again, where as you go up and as you go to the right, the ionization energy increases, predict which element would have the largest ionization energy of these over here. So what you're looking for is which element is furthest to the right and furthest up. So the correct answer is helium. Helium actually has the highest ionization energy of any of the elements, and that is because, again, our trend is they go up and to the right. That is in the top right corner, the highest ionization energy. All right, our next pattern we're going to look at are the atomic radii. And so these are approximations. These aren't perfect, obviously, because it's not super easy to visualize what a single atom looks like. But this kind of gives you a visual of the difference in size of different atoms. And so what we might notice here, and we just call that the radius. Think about a circle. That's literally how you define how big it is. But it's pretty clear that the smallest radii are in the top right corner, and the biggest ones are in the bottom left corner. All right, so based on that trend, again, remember that the arrows point in the direction that it is increasing. The atomic radius blank as you go up the periodic table. So if I go up the periodic table, what's happening to the atomic radius? Right, so they get bigger as you go down, but as you go up, it decreases or gets smaller. Okay, what about as you go left to right? Same thing. It's against the trend. So the trend shows that it gets bigger as you go from right to left. This question here asked you to tell me what happened as you went left to right. It would be decreasing. Okay, so if we look at this example here, the noble gases are these elements over here, and our alkali metals are these over here. So would a noble gas have a bigger or smaller atomic radius compared to an alkali metal? And it should be really clear these noble gases have a way smaller atomic radius than these elements over here on the left side, because the trend is for those to increase as you go across. All right, so again, using this idea where the trend shows that as you go down the periodic table and as you go from the right to the left, so down here being the biggest, up here being the smallest, which of these four listed elements would have the largest atomic radius? Great. So the one that is to the left the furthest and that is down the furthest is good old francium. So like radon, that's pretty far down, but it's all the way on the right. Helium, it's all the way up at the top. That can't be it. Helium, that's the opposite. It's the smallest. Okay, our answer is B, francium. All right, electron affinity. So this is another one of those that you don't exactly need to know what it means. You're going to see electron affinity and electronegativity. Again, this just has to do with forming ions and the amount of energy that it takes, and how either gaining or losing electrons. Okay. So the main idea here is, again, that if we look at as you go up the columns, you'll see that the electron affinity number is increasing. And then you'll notice that as you go across, again, there's a couple of little slip ups, and there's some reasons for that, but don't worry about it. But as you go across, it also, the electron affinity also increases. You'll notice that the noble gases all have 0. Well, that's because they don't want to get electrons, and so it ain't going to happen. All right, so electron affinity, its general trend, again, follow the arrows, okay? Electron affinity blanks as you go up the periodic table from the bottom to the top. So our arrow points from the bottom to the top, so the electron affinity increases as you go up. As you go, what happens to the electron affinity as you go from left to right? Right, so the electron affinity also increases as you go from left to right. Okay, so let's see if we can make this one work. This is, I'm going to make you think real hard. When the atomic radii increases, so remember the atomic radii is going to increase when you go from right to left and when you go down. What happens to the electron affinity, which actually it increases if you go up and to the right? Right. So if the atomic radius is getting bigger, that means that the electron affinity is getting smaller. Okay, because the electron affinity increases as you go right and up, which is the opposite of the radius. Okay, so let's answer this one. Based on that understanding, again, that electron affinity increases as you go right and as you go up, which of these statements is true? Electron affinity tends to increase as you, A, go down a column of the periodic table, B, go from left to right across the periodic table, C, go toward the middle of the periodic table, or D, go from the upper left-hand corner to the lower right-hand corner of the periodic table. So the only one of those that makes sense is B. Right? So as you go from left to right, It's not going down the column. We see that that's actually the opposite. We haven't talked about going towards the middle at all. That's kind of crazy. And the left-hand corner, then going to the right-hand corner, there's not really an easy trend to follow there. All right, our last one we're looking at are metallic character, and that literally just means how much of a metal something is. And this pattern we'll see, the arrows are pointing increasing metallic character as you go from right to left and as you go down. So all that means is the most metallic stuff, or the most metallic is going to be in the bottom left, and then the least metallic is up in the top right. That makes sense because those things are literally not metals. They're called nonmetals, so they wouldn't have any of these metallic characteristics. All right, so as you move across the periodic table from left to right, so from left to right, what happens to the metallic character? It decreases. Good. All right, so of the elements below, which then would be the most metallic? So with this question, you're looking for which one is further to the left and further down the periodic table. Which of these three would that meet? Great, so the correct answer is K. If we look at K over here, there's magnesium, there's aluminum, and there's helium. That K is the furthest to the left and furthest down the periodic table. All right, so like I said, we're going to spend more time with this, but I wanted to get you guys comfortable being able to look at these trends, look at these patterns, and make some predictions and understand how some of these charts work and how to read them. Because what's going to happen is you are going to be given a brand new element that has been discovered. It hasn't really, but you get the idea. And you're going to be given a set of characteristics about that element. And then based on the characteristics of the element and the general trends of the periodic table, you're going to predict where that element should go on our periodic table. So to help prepare for that, you do have a Edpuzzle assignment number 63, periodic trends Edpuzzle. The guy is pretty much talking about a lot of the same stuff we just did together. But I think that the more you have work in front of it and access to it, the more comfortable you'll be when you have to do it for this bigger assignment. Okay. So that is what you should be looking forward to next week. So please make sure that you're in our live lesson both days next week so that we can make sure that you get this done as well as possible. So before I send you guys out, I just want to get an idea of how you're feeling after this lesson. Was that a lot? Was that okay? Does it make sense? Do you need to do the Edpuzzle in practice? But how are you feeling about this content after that lesson? Thank you guys for sharing. So like I said, this week there are 4 assignments. You hopefully have already done the preview. You hopefully already did your lesson 26, either live or recorded, and have worked on 62, the scavenger hunt. Then with this lesson, after you've watched this lesson, now you can go and give number 63, which is the Edpuzzle, a shot, as well as this reflection question. Okay? So those 2 new assignments should be posted on there. Everything is technically due on Sunday at midnight. But as always, you know that I'm accepting late work whenever you can get it done. If you're putting in the effort, I'm going to reward it. All right, I'm going to send you guys out. Please let me know if you have any questions or if you need any help. Otherwise, I will see you next week. Thanks.